Good morning, students. Today we shall discuss about the new chapter, that is nanomaterials or nanoscience. Nanoscience is a new field, or it is the broad field. It is not a new field, it is a broad field. It is connected to both chemistry, physics, medicine, material science, and also applied technologies. Okay, here nano science is the field of the science. It is a broad field. It is connected to both physics, chemistry, medicine, material science, and applied technologies. It is having vast applications. Vast applications. Here the nano is comes from the Greek word, that is dwarf, dwarf. Nano is comes from the Greek word, derived from the Greek word, that is dwarf, dwarf. Dwarf means extremely small particles. Extremely small, we are calling it as, meaning of dwarf is extremely small. That's why the nanomaterials, extremely, we are calling it as extremely small particles. Nano is, nano word is comes from the Greek word, that is dwarf, dwarf. Dwarf means extremely small. The nanomaterials, definition of the nanomaterial, it can be defined as, it is the materials, it is the material whose dimension is lies between 1 to 100 nanometer. It is the material whose dimension is lies between 1 to 100 nanometer. This is the definition of the nanomaterial. Nanomaterial is the material whose definition is, whose dimension is lies between 1 to 100 nanometer. Next, we shall discuss about the synthesis of nanomaterials. Synthesis of nanomaterials. The nanomaterials are synthesized by two different methods. It can be synthesized by two different methods. One is bottom up approach, another one is top down approach. There are two methods of synthesis of the nanomaterials. One is bottom up approach, another one is top down approach. In the bottom up approach, it is having the smaller components are arranged themselves into a complex assemblies. Okay, in this diagram we can you can see that here in the bottom up approach, from the bottom it has to be converted. Here the from the bottom, here the smaller components are arranged themselves into complex assemblies. Smaller atoms or molecules are converted into the larger molecule, larger nanomaterial. Here in case of the top down approach, larger one or larger component is converted into smaller particle. That is called as top down approach. Bottom up approach means smaller components are arranged themselves into a complex assemblies, whereas in top down approach the larger nano material is converted into a smaller particles. Larger nano material is converted into a smaller nano particles. Okay, in bottom up approach, the nano material is built up by assembling building blocks. In bottom up approach, the nanomaterials are it is a built up by assembling building blocks, that is atoms or molecules. As I already said, the in the bottom up approach they are combined atom by atom or molecule by molecule to or cluster by cluster to form a bigger nanomaterial. Here the in the bottom up approach, the atom, the bigger nanomaterial is formed by combining atom by atom or molecule by molecule or cluster by cluster to form the bigger nanomaterial. But in case of top down approach, the larger material is cut down, larger material is cut down into smaller nanoparticles or nanomaterials. Okay, have you understood? There are two types. One is bottom up approach, another one is top down approach. in the bottom up approach, the smaller components are arranged themselves into complex assemblies, that is the bigger particle or bigger nanomaterial, where in case of top down approach, the larger nanomaterial is cut down into a smaller particles. Okay, here in the bottom up approach, then larger material is formed from the bottom by combining atom by atom, molecule by molecule, or by cluster. Okay, but in case of top down approach, the bigger nanomaterial is cut down into a smaller nanoparticles or nanomaterials. This is all about the bottom up approach and top down approach. In these two methods, usually the synthesis of nanomaterial is done by the bottom up approach. We are preferring the bottom up approach compared to top down approach, because the bottom up approach, it is having less defects. You will get the nanomaterial with less defects and more homogeneous chemical composition. By using the bottom up approach, the nanomaterials or nanostructures are synthesized with less defects and more homogeneous chemical compositions. This is the one advantage of the bottom up approach. And top down approach, why we are not preferring the top down approach means because it is having internal stress. The nanomaterials are associated with internal stress between the atoms, and also it is having more defects. For this reason, we are not preferring the top down approach. Okay, bottom up approach, why we are preferring bottom up approach? Because the nanomaterials are synthesized with less defects and more homogeneous chemical compositions. Nanomaterials are synthesized with less defects and more homogeneous chemical composition, but in case of top down approach, it is having more defects, and in case of top down approach, the atoms are associated with internal stress. There is an internal stress between the atoms or molecules in nanomaterials in case of top down approach. That's why compared to top down approach, bottom up approach is suitable method for the synthesis of nanomaterials. Next, we are going to deal with sol-gel process. Sol-gel process is one of the process or one of the method of synthesis of nanomaterials. It is a method of synthesis of nanomaterial. It comes under bottom up approach. It comes under one of the method of bottom up approach. It comes under bottom up approach. Here, the sol-gel process is the process by which we can synthesize the nanomaterial. Novel nanomaterials are synthesized by using sol-gel process, and relatively low cost nanomaterial. We can synthesize the nanomaterial with less cost or low cost by using sol-gel process. Here, before we are going to discuss about the sol-gel process, we must know about what is meant by sol or gel. You have already studied the colloidal chapter or regarding colloids in the lower classes. These are the colloidal particles. The sol and gels are the colloidal particles. Okay, what is meant by sol? Sol is a colloidal solution or colloidal particle where the solid particles are dispersed in liquid phase. Sol is the colloidal solution where the solid particles are dispersed in liquid phase, or gels are the colloidal particles where the liquid particles are dispersed in solid phase. Have understood? Sol-gel is a process by which we can synthesize the nanomaterial with novel nanomaterials are synthesized by sol-gel process with low production cost, And before we are going to discuss about the sol gel method, we must know what is meant by sol and gel. As I already said, sol and gels are the colloidal particles or colloidal solutions. Here, what is meant by sol? Sol is the colloidal solution where the solid particles are dispersed in liquid phase. Gel is the colloidal solution or colloidal particles where liquid particles are dispersed in solid phase. Many of gels you are using in our day to day life. You have come across many of the gel products which we are using in our day to day life. You have already seen many of the gels which we are using. Okay, this is all about sol and gel. Then what is meant by sol gel process? Sol gel process, it consists of chemical transformation of the sol into a gel state. Here, what is sol gel process? Here it consists of, sol gel process consists of chemical transformation or chemical conversion of sol into a gel state is called as sol gel method or sol gel process. Have understood? Here the chemical transformation of the sol into a gel state is called as sol gel process. The sol gel process involves the following steps. First step is preparation of the precursor. Precursor means here the raw material which is used to synthesize the sol. What is precursor? Precursor is the raw material used to synthesize the sol. Here usually we are using inorganic or organic precursors. Inorganic or organic precursor, but in this process we are preferring the organic precursor, that is MOR. We are preferring the organic precursor, that is MOR. Usually inorganic and organic precursors are used. What is meant by precursor? It is the raw materials used to get the sol, but in this process we are using the organic precursor. The name of the precursor is metal alkoxide, that is MOR, where R stands alkyl group. R stands alkyl group. MOR we are using in this process. Here in this method, in this step, the MOR in this step, the MOR metal alkoxide is undergoes a series of hydrolysis and polycondensation reaction. In this step, the metal alkoxide precursor undergoes a series of hydrolysis. Hydrolysis means addition of H2O, water molecule. Series of hydrolysis and polycondensation reaction. As you already know what is meant by condensation. There are two type of polymerization. You have already come across in the polymer chapter. You have already come across the condensation polymerization. Condensation polymerization is one type of polymerization where the polymers are formed. Polymerization takes place between two different types of monomers. Types of monomers. Here the polycondensation and hydrolysis reaction takes place between metal alkoxide and H2O. Then we will get the MOH. In this step, the alkoxide OR group is completely replaced by OH group. MOH we are calling it as sol. MOH we are calling it as sol. OR is alkoxide group is completely replaced by OH. This is the preparation of the precursor. Precursor means it is the raw material used to synthesize get the sol. Usually inorganic or organic precursor we are using. In this method or in this sol gel process we are using the organic precursor. The name of the precursor is MOR, metal alkoxide, where R stands alkyl groups. Here in this step, the metal alkoxide undergoes or precursor undergoes a series of hydrolysis and polymerization reaction, then we will get the MOH. MOH is the sol. Here the OR, in this step the OR alkoxide group is completely replaced by OH group. MOH we are calling it as sol. MOH we are calling it as sol. Once you will get the sol, in the next step, formation of the gel phase. In this step, the polycondensation reaction between MOH and MOR. MOH and MOR, as you already know, MOH is the sol, MOR is the metal alkoxide. When the reaction between MOH and MOR takes place, then we will get the oxide or alcohol bridged network. Oxide or alcohol bridged network. MOM we are calling it as oxide or alcohol bridged network, that is called as gel. For MOM we are calling it as gel. Next step is formation of the gel phase. Formation of the gel, second step is formation of the gel phase. Here in this step, the polycondensation reaction between MOH and MOR, whatever we are synthesized earlier in the earlier step, MOH, that is to be reacts with MOR, metal alkoxide, then we will get the MOM. MOM means it is oxide or alcohol bridged network, that we are calling it as gel. Next step is preparation of the gel. The third step, the third steps includes aging of the gel. Third step involves the aging of the gel, where the polycondensation reaction is to be continued. Polycondensation reaction is to be continued until the gel transforms into a solid mass. Here in the aging of the gel step, the polycondensation, as I already said, the condensation polymerization is the type of polymerization takes place between two different types of monomers. Takes place between two different types of monomers. Here in this step, aging of the gel, the polycondensation reaction is to be continued till the gel transforms into a solid mass or solid phase. In the gel is earlier it was in the semi liquid or the in liquid form, that has to be converted into a solid mass by expulsion of the solvent, removal of the solvent. When you remove the solvent, then it is converted into a solid mass. This is about aging of the gel. In this step, the polycondensation reaction is to be continued, where the gel is transformed into a solid mass by expulsion of the solvent, expulsion of the removal of the solvent from the gel pores. Okay, next step is drying of the gel. In the next step, drying of the gel. Drying means water and other any volatile liquids. Water and other volatile liquids are removed. Water and other volatile liquids are removed in this step. Then we will get the two nanomaterials, that is xerogel and aerogel. Xerogel and aerogel. In the drying of the gel step, water and other volatile liquids are removed. Water and other volatile liquids are removed. Now then we will get the xerogel or aerogel. These are the two nanomaterials we are getting from this step, by this step, that is drying of the gel. Then in the next fifth step in the sol gel process, fifth step is the dehydration. In this step, surface bound MOH groups are removed, surface bound MOH groups are removed by heating, the gel, or by calcining. Calcining means heating of the gel up to 800 degrees centigrade. Calcining means heating of the gel up to 800 degrees centigrade. Then if any MOH groups are there, those can be removed by heating that gel up to 800 degrees centigrade. This is to be carried out by calcining process. What is calcining? Calcining means heating of the gel up to 800 degrees centigrade. By calcining, if we can remove MOH groups if they are attached to the gel network. Here last step is densification and decomposition. In this step, the gel is to be heated above more than 800 degrees centigrade to remove the pores. If any pores are there in the gel network, those can be removed or collapsed by heating the gel more than 800 degrees centigrade. And if any organic contaminants are there, those can be volatilized in this step. If any organic solvents are there, those can be removed or volatilized in densification and decomposition step. These are the ultimately at the end we will get the nanomaterials. These are the synthesized, the diagram explains about the synthesis of the nanomaterials. Here, this is the block diagram of the sol gel process. Where we are getting the sol is to be converted into a gel. Okay, I will repeat the sol gel process once again. In this what is meant by sol gel, it is very important for your examination. Compulsory they will ask this question: sol gel method or sol gel process. Sol gel process is the process by which we can synthesize the nanomaterials, novel nanomaterials are synthesized by using sol gel method. In this method, the chemical transformation of the sol into gel takes place. Chemical transformation of the sol into a gel phase or gel state, we are calling it as sol gel process. Here, before we are discussing about the sol gel, we must know about what is meant by sol and gel. Sol and the gel are the colloidal solutions. What is meant by sol? Here the solid particles are dispersed into a liquid phase is called as sol, and gel means liquid particles are dispersed into a solid phase is called as gel. Here the chemical transformation of the sol into gel takes place in this step, in this process. Sol gel process involves the following steps. First one is preparation of the precursor. As I already said, precursor is the raw material used to get the sol. Usually organic and inorganic precursors are used in this process, but we are using the organic precursor, that is MOR, where R stands alkyl group. MOR is the metal alkoxide. Where R stands alkyl group. In this step, the precursor is subjected to a series of hydrolysis. Hydrolysis means addition of H2O. Hydrolysis and polymerization reaction. Series of hydrolysis and polymerization reaction. Then we will get the MOH. MOH is the sol. Here When MOR, metal alkoxide, reacts with H2O, then we will get the MOH, where OR, alkoxide group is completely replaced by OH. Completely replaced by OH. Next step is formation of the gel. Formation of the gel. Here in this step, the polycondensation reaction between MOH and MOR takes place. Then we will get the MOM. MOM is the alcohol or oxide bridged network. That is, we are calling it as gel. MOM we are calling it as gel. In the third step in this process, aging of the gel. In this step, the polycondensation reaction is to be continued till the gel transforms completely into a solid mass. Gel transforms completely into a solid mass by expulsion of the solvent, by expulsion, removal of the solvent from the gel network, by expulsion of the solvent from the gel network. That is called as aging of the gel. In the fourth step, it includes drying of the gel. Drying of the gel. If any water and other volatile liquids are there, if any water and other volatile liquids are there, those can be removed. In this step, ultimately we will get the two types of nanomaterials, that is gels, that is aerogel and xerogel. Aerogel and xerogel. Next one is dehydration. In this step, the surface bound, if any MOH groups are bonded with gel network, those can be removed. Surface bound MOH groups are removed by calcining process. Calcining is the method in which the gel is heated up to 800 degrees centigrade. When you heat the gel up to 800 degrees centigrade, if any MOH groups are bound, those can be removed in this step. In the last step, densification and decomposition. Densification and decomposition. The same gel network is to be heated more than 800 degrees centigrade to remove the pores or holes from the gel networks. Those can be collapsed, and if any organic contaminants are there, those can be volatilized in this step. This is all about sol gel process or sol gel method. Sol gel method is the one of the method by which we can synthesize the nanomaterials by chemical transformation of the sol into gel. Another two methods are there that we shall discuss in the next class. Okay, thank you.